Thank you. So, as I was saying, in a molten solution of lead bromide, we have two mobile ions. These are the things that are going to conduct electricity because they can move. Okay. So in this solution here, which looks like a smiley face for some reason, you have a mixture, not a mixture, but more like a solution of ions. Well, then how do the ions move? Hmm. Việt Anh, Việt Anh, can you hear me? My microphone is broken. Oh, well, then you definitely need to show your face. And also, me, Zamin then.
Yes, I'm here.
Sure. And where's your camera? Hello. Mm, no signal from his side. Oh, anyway, let's continue. Now, Vidang, you need to do something about your microphone and your camera. And as for, hold on, let me check the name. And as for Zamin, your camera is here. So, can you turn on your microphone?
Oh, yes.
Well, what happened to the particles here? Where do they move? We have the positive electrode on the left and the negative electrode on the right. So how will the particles move?
Or maybe because of the wire is made of metal and metal have a free electron that can move easily.
I don't think that's the nature of the question. I'm asking about the movement of the ions. So let's say this, let's consider this anion. Well, where will it move? Will it go to the positive end or the negative end?
It goes to the positive.
Hmm, right? So we got, and this anion also to the negative, to the positive end. Positive, and then hold on, work with this positive. And the cation, of course, will move to the negative, right? Mm. Oh, let's move some more. Z work. Okay, so opposite attracts. So what is shown here is that the anions will move to the positive end, right? And the cation will move to the negative end. So the positive charge, so the positive electrode is also called the anode, and the negative end is also called the cathode. All right. So now we have anode for anions and cathode for cations. What would happen now in these electrodes? You did this at school, so I'm just asking questions. That's why. In Hưng, please. For anodes, we have Br2 plus anions. And at cathode, we have Pb2 plus, sorry, Br2 plus, sorry. Yeah. So what would happen to these ions?
Uh, they they get stuck onto the cathodes.
Mm, essentially, they form products. But what would happen here?
The the lead particles would get pulled towards would get stuck onto the cathode and then become a chunk of lead. Well, the
Mm,
bromine, which is uh become a gas and form bubbles.
bubbles, not a gas. But maybe because of the energy, you might see the gas form. Sure, it's more like a liquid, but how can you get these products then? Let's try to find an explanation. From Br minus to Br zero, what must happen to the electrons?
Oh, it loses an electron.
Okay, I think that for your program that you're more familiar with this form, right? Each bromide ion is going to lose one electron to form Br0. But because Br0 often exists in the diatomic molecule form, like Br2 here, you need two Br minus, right? And how can you get Pb here?
It's two electrons.
Plus two electrons, right? So these are the half equations, and that should give you the net equation of this electrolysis process. You get Pb and Br2 with the phenomena described very nicely by Hưng. Okay, good. Now let's do a bit of redox revision. Cho, can you hear me?
Yes.
Okay. Um, from Br minus to Br0, what process are we looking at?
Uh, can you speak again? Repeat.
From Br minus to Br0, what process are we looking at?
Process.
Yes.
Um, like a
Reduction
reduction,
or oxidation?
oxidation. Oxidation.
Oxidation. And this process down here,
Reduction.
reduction. Nice. So that's an example of an application of electrolysis, right? For certain compounds, you cannot get their like pure elements form by any other method, so you have to employ the use of electricity because electricity can deal with electrons, and you know that valence electrons are supposed to you know bridge connections and form new bonds. So if you can manipulate them, you can create new substances. Or in this case, you break down compounds to form elements. Okay, so here in this, let's say the negative electrode, the electrons would jump. Can you see this stuff? Maybe a different color. Yeah. So these tiny electrons would jump from the anion into the anode. And you know that there are lots of electrons here. So the presence of electrons will push other electrons along the way up the wire here. The electrons here will also move, right? All the way here back to the positive electrode. And then again through the negative electrode down here, as long as the switch is off, down here. And the electron and you have some electrons here, right? Because these electrons are pushed down, they will then jump to the cations, right? To form the solid metal. Okay, so any question regarding the first example of electrolysis?
How can the electron be transferred in the negatives, like the cathode side?
Cathode?
Ý là cái có dấu trừ à? So like,
Yeah.
why don't they repel?
Oh, the repulsion starts here. It goes like this, right? Because the anions here are attracted to the positive electrode. You see that?
Yes.
Okay, good. So because the anions are attracted to the positive electrode, these anions carry negative charges, right? So they're attracted to the positive electrode. So with the help of the force created by the battery, the electrons would jump from the anions into the positive electrode. Got it?
Okay.
Good. So they move up, and the new electrons will push the old electrons up.
Okay. Okay.
And it goes through the circuit down here to the negative electrode. The negative electrode has electrons, lots of electrons, so they attract cations. Okay,
Okay. Okay. I get it now.
good. So the cations here have positive charges. These are like lead 2 plus ions. So because they have a positive charge, and this electrode already contains lots of electrons, these electrons will be compelled to jump into the cations. And of course, when that happens, this reaction occurs. Pb2 plus takes 2 electrons to become Pb. Does that address your question?
Yeah.
So you're assuming that this negative electrode will repel electrons, but the electrons are the reason why they have the negative charge. That makes sense.
Yeah, low key.
Okay. So any question regarding this part? Because after this, we're going to jump really fast. People?
Yes. You can continue.
Well, we'll continue to a break. I want to give you a 10-minute break, and then we will go through a few other examples in this particular chapter. All right? Well, this is all that we have done in the past 50 minutes because we did have a 7-minute warm-up with a game, and I spent 3 minutes on roasting Chuan for munching down on that. What were you having again, Chuan?
Bánh cuốn ạ.
Yes, I was essentially throwing her under the bus for eating bánh cuốn. Yeah. So we're gonna have a 10-minute break, and I'll see you at 10. Okay, people, let's continue. Can you hear me? And I have a question. Who is that man behind your back?
It's like a standee of my idols.
Is he interested in electrochemistry?
I don't know.
And he's smiling.
Yes.
And who's that man?
It's DK from 17. Like
Is he
K-pop group.
17 years old?
No, he's in a group named 17.
Oh, are they big? And I have a question. Are they big? Are they like superstars?
Uh, yeah.
Why did you have to wait for that? Well, okay. You got a standy. Like, I have a question for you too, and like because your room is so interesting. Like all the other boys just have boring rooms. Um, like when you get up at night, do you get startled? Like, why is this man in my room? Did he ever mistake him for a ghost?
He's been there since I remember like 5 months ago. So I have get used to with it.
Okay. But at the beginning, did anybody try to, do a drop kick on him because they thought that he was an intruder,
Oh, my
a
dad.
friendly intruder at that?
No. But like my dad, the first time I bring him to my room, so when my dad walked through my rooms, he's like a little bit afraid because like just say hi.
He tried to have a conversation with a man.
No.
How cute. How adorable. Now the boys here need to do something. I'm not quite sure who. Let me just ask a few questions, then we're gonna move on with the lesson. But then, um, Hưng, then where's your camera? Hưng, are you back? No, no response from his side. But then, Khang, then, if you had a standee of someone in your room, who would that be?
I don't know. Maybe Mike Tyson
Oh, so you're into boxing.
or Verstappen.
What? Oh, sorry, who?
Verstappen, the F1 drivers.
Oh, right. So you would have a man in your room. Okay. Well then one more question, then we move on then. Cho, who would you have in your room as a standee?
You asked me?
Yes.
Oh, I would definitely have a study of myself. Yes, because I love to watch myself when I'm sleeping. So I'm reminded
Well,
that I am very beautiful.
are you all in the same class?
Yes.
And what kind of B are you?
B4.
E4? Okay. Are you all like on the same wavelength when it comes to this level of self-obsession and delusion?
No, I think I'm more specially built.
Yes. I think that your answer sort of served as a testament to that. Okay, let's move on then. That was an amusing conversation, but Hung and V are still not anywhere to be found. 1, 2, 3, 4. Are we supposed to have like 7 kids here? Ming is here, Kang is here, Hung is here,
I'm
V is here.
sitting next to Vietnam.
And where's Vidang?
He's here.
And why are you two together?
Because we're using the same internet, so that it's faster.
Oh. So you guys are in the same room?
Yes,
How did you end up in the same room?
because I just moved there, like this morning. Sorry.
What does that mean?
I just
So you're
moved there.
paying him a visit?
Yes, I'm visiting his home, his house.
I bet that's a massive house. Am I right?
Mm,
Oh.
I think so. It's an apartment.
But then that does not count as a house unless that apartment is a penthouse.
Yes, I know. He's not.
But is it a penthouse?
Uh, I think he's technically an animal, so maybe.
Yuan, do you have anything to say for yourself?
Maybe.
Do you have anything to say for yourself?
I don't know. He accepts it.
Okay. But then again, in a lot of our parents' eyes, we're practically living in a tomb, right? Right. But is that a messy room then?
No, it's clean, but like it's more of a ổ chuột.
Mhm. Okay, look, I do think that Joe, you have a personality. Um, but don't get it twisted. We have to stay focused. All right, we're gonna move on with other examples. Let's talk about NaCl, sodium chloride, but in molten form. In molten form, what are two ions that we're gonna get? Ming, please.
Can you repeat the question?
Sodium chloride, when we melt it, what are two ions that we're gonna get?
Well, we'll get sodium and chloride.
Na plus and Cl minus. Okay, but then why would this molten solution conduct electricity?
Well,
Ming.
because the electron is like free decentralized, so they can move in the molten.
No, not the electrons. Oh my God. We spent the first 10 minutes of this class, during which you were absent, if I'm not mistaken. Were you absent during that time?
Yes, I come in the class by 9:30.
Oh, let me explain again. Well, when it comes to ionic compounds, you're not actually referring to electrons. The thing that allows the whole system to work or to conduct electricity is the mobile ions, these ions themselves. Okay? So not electrons. You're looking at ions. Now, tell me where you can find the ions. The same principle then. Anode attract what kind of ions and cathode what attract what kind of ions? V, please.
I think anode is positive and cathodes are negative.
We're gonna start with anode is for anions or cations.
Oh, sorry, it's for anions and the other is cations.
Good. Anions. And of course, then you can like just memorize everything by heart if you want. And well, anions carry the negative charge, so they will move where? V, continue. V.
I think they
Cl minus. That's an
yeah,
ion, an anion. So where does it go?
it goes to the negative side, which is the
No,
right.
no. Cl minus, it has a minus charge, so it's going to be attracted to a
Oh, my
positive
bad.
charge. right? Here. Okay, so that means Na plus will go where?
Negative.
Good. Now, at anode, Cl minus, at cathode, Na plus for now, because there's no other ion, so sodium's got to move it. Well then, what's gonna happen here? What's gonna happen at anode? Let's continue. Hung, please. Is Hung in the building? Hung. Hmm. Where is he? Well then, Khang then, what happens to chloride ion here?
It loses its electron, so it becomes chloride with no charges.
Chlorine, in that case, chlorine.
Yes.
Without any charge, what is the oxidation state?
0.
Good. And you know that chlorine often exists in the form of a diatomic gas. So you have two here, and it's gonna lose 2 electrons. Are the charges balanced on both sides? Kang, that's the question for you.
So sodium would get the electron
I'm
and
talking
becomes
about the anode.
I don't know how to answer the question.
Just check the charges. On the left, you have 2 negative. On the right, we also have 0 plus 2 negative. Because each electron accounts for 1 negative charge. So are the charges equal?
Yes.
Good. Let's continue then. For cations, we have sodium in this case because it's molten. So what will happen to sodium? Continue. We're on a roll here.
So the sodium would get the electron from the chloride ions,
To form what?
from the chloride ions plus E minus. So it would result into sodium itself.
Good. Solid. Good. And in reality, this is practically the only way for you to actually get, a pure sodium from a compound. Because sodium is a very reactive metal. It's really up there with potassium, lithium, and all of the group 1 relatives. Right? So the net equation for this would look something like this. You need Na plus Cl2. You have to pay attention to the form of the substance here. It's Na, but it's Cl2 because that's how chlorine exists in nature. How can you balance this equation? And you see a 2 in Cl.
So it's gonna 2 NaCl.
Good. You need 2 here. And from 2 here,
Yes.
2 here. Okay. And remember, we're talking about molten sodium chloride, which means there's only either sodium or chloride. Now we're going to move on with something else. This is NaCl, but NaCl with water. NaCl plus water. And we're going to do the same analysis. We're going to list out all the possible ions that exist, in this solution, and then we're going to talk about their distribution, right? You get the point. Hung, please. This is the third time I've been calling your name. Where is that boy?
I think he mistakes the break for I think like 1 hour.
Geez, you're adding fuel to the flame. Okay, well then, can someone call him up? V,
I don't have his contact.
really? V, can you give him a call?
I don't have his contacts.
What?
Like he's not online on the social media platform that we have contact with him, like Messenger or something.
So you don't have his number, that is.
We don't really add each other numbers.
Oh. Well, there's a saying that goes like, if you have a problem with me, you can call me. And if you don't know me enough if you don't know me well enough to have my phone number, you don't have a problem with me. I thought you're from the same batch. Well, it's for the better, I guess. I want to send a text message into the parents group. That's really going to stir the pot. Okay, let's continue. Now let's talk about the ions here. So this is sodium chloride dissolved in water. So what are the ions that you're going to get?
Chloride, anion,
Good,
and sodium plus.
good. And from water, what do we get?
Hydrogen plus and oxygen 2 minus.
Oxygen? No, OH minus.
Oh, okay.
Okay. So this is the dissociation of water. In
Okay.
the liquid form, water can not dissolve, but dissociate or split into H plus, which is responsible for what property here, Cho?
Cation. It's a cation.
It's acid. OH minus would be
The anion. The alkali.
Okay. You see how many cations here? Việt Anh? We see how many cations?
2.
Which are?
C chlorine and
Cations, the positively charged ones.
Sodium and the
And
hydrogen.
hydrogen. And then we have the anions, which are chloride ions and hydroxide ions. Now at cathode, hold on, what's going on? Right here. At cathode, we have Na plus and H plus. And at anode, we have Cl minus and OH minus. Now we're gonna have to choose which of these ions are gonna react first. And let me give you a hint here. But before I give you a hint, can you make a prediction? Which is gonna receive electrons at the cathode first?
I'm guessing sodium.
Well, let me give you a hint. Do you remember the reactivity series?
Yes,
So is sodium more or less reactive than hydrogen?
it's more reactive.
It's more reactive. So it's more likely for sodium to give electrons, right?
Yeah.
So if sodium is already more likely to give electrons, is it more or less likely to receive electrons?
More likely to receive.
less likely. You cannot have it both ways. You cannot have your cake and eat it too. If sodium is already more likely to give electrons, it's going to be less likely to receive. So in this particular solution, hydrogen will be the first one to take electrons. The H plus is going to receive electron to form what now, Joe?
Hydrogen 2 diatomic.
H2. So you need two H plus, and it's going to receive how many electrons?
2.
2 electrons. Good. In this case, sodium will not have a chance to receive electrons at all because you have lots of water here, right? Now for anode, the thing about anode is that it has 2 anions, all right? So 2 possibilities can happen. If you're looking at a very saturated solution, you might get Cl minus losing electrons to become Cl2, right? But for normal dilute solution, OH minus is actually going to lose electrons to create oxygen. And this is the equation for it. Right? Okay. People got it. There are 2 situations here. You can get either Cl2 or O2, depending on the concentration. Joe got it.
Yes.
So if we take the net equation will be the combination of everything, NaCl plus water, and we're using very saturated solution. What other products are we going to get? Yeah, based on these equations, what are we going to get? Hưng, please, can you hear me?
Yes.
Also, where were you?
I was sleeping.
Oh, are you sitting in an air-conditioned room?
Yes.
And did you just mute this class?
What do you mean?
Well,
I went to sleep during the break time and I forgot.
of course, but you couldn't hear anything from us, as in me, most of the time.
Also, I'm wearing headphones right now, so I'm not using a speaker or something.
Oh, so my voice is locked in your earphones.
Yes.
Fired. Okay, well then welcome back. What were you dreaming about?
It was instant. There was no
What?
dreams.
Oh, what a waste of time. You should have dreamt about something. Maybe chicken wings. But anyway, so this is the net equation. What we're gonna get here as products for a concentrated solution of sodium chloride. Yeah, so what are the products we want to get here?
Sodium and
Nope, definitely not sodium. Sodium is not even electrolyzed. You will
chlorine.
get definitely chlorine, definitely H2. Chlorine will be found at anode, hydrogen, cathode, based on these equations. And then we have Na. We have Na will combine with OH minus to form NaOH, right? And we put number 2 here and 2 here. And I guess 2 here. And everything is balanced out. Okay? Any question? No? Okay, let's continue then. The electrolysis of copper sulfate in water. What color is copper sulfate? Việt Anh,
Can you
do
repeat
you remember
the
this?
question?
What color is copper sulfate?
Blue.
Blue. Sorry, not this ugly pale blue. It's a different kind of blue.
Dark blue. Is it?
Yes, it's very vibrant. Almost purplish. We don't have that here, so I guess we can just go with something like this. Yeah, the original color. Okay, we're gonna do the same thing. We're gonna draw the electrolytic cells. What are the cations here? Just find the ions for me. Việt Anh, do we have Việt Anh in this class?
Yeah.
Okay. So from CuSO4, what do you get?
Cu.
How many plus?
2, 3.
2 plus. SO4, sulfate.
2 minus.
Good. You can sort of explain these numbers, but I think it's just easier for you to memorize them through practice. From water, what do we get?
Hydrogen and hydroxide. And OH.
Minus. Good. Now, which ions will go to the cathode? To Anne, please. The one with DK in the background.
It's Cu2 plus. No, Cu2 plus
N.
and H plus.
Good. Anode.
SO4 2 minus.
N.
Is that O and H?
OH minus.
Okay.
Okay. Now, a cathode, please. Which of these ions is going to receive electrons first? And of course, the hint here is the reactivity series. Please stop calling me a zebra instead. Help, copper, save gold. So the help, copper, which one is superior? And
Copper.
no. Help, copper. Hydrogen is above copper. So hydrogen is more likely to lose electrons. Copper is more likely to
Gain electron.
good. Right, you can't have your cake and eat it too. So if you have already got the ability to gain electrons, you're not going to have the ability to lose electrons that easily. So copper is going to take electrons first. And the observation here is that you're going to see a layer of brown solid at the cathode. Okay. Good. Now for anode here, just take a vote then, and which one is easier to break in your opinion? SO4 2 minus or OH minus?
OH minus.
Well, today is your lucky day because that was correct. But then what are the parts you're gonna get here?
I
From
think
OH minus, you're gonna get O2 first.
yes,
And
and
then
electron.
yes, and water. 4 electrons here. So 4, 2, and hold on, 2 and 2. Doesn't make any sense. Oh, sorry, not 2 here. Okay. Good. So what is the overall equation? What are the parts? You definitely get
Cu
good. Sorry. You definitely get
plus O2
mm, Now we have SO4 left. So SO4 is going to combine with H plus to form H2SO4. Now balance the equation, please.
2 Cu and 2 oxygen.
2 oxygen.
Yeah.
You definitely need 2 for SO4 first. And for oxygen, as you can see, you have only 2 left, and this is already 2.
Okay.
Right? So this is the balanced equation. Okay?
Yeah.
Good. Well, we have gone through most of the chapter. Yeah. Okay. Hold on. For the case of here, we have for the case of copper electrodes. When we use copper electrodes, in this case, let's say like this. If we use copper electrodes, then you have the positive, negative, you have copper here. Well then, if you use CuSO4 as a solvent, then what might happen at the electrodes? You get Cu2 plus, SO4 2 minus, H plus, and OH minus. I want to pay attention specifically to aqueous copper sulfate when using copper electrodes. Now, let's talk about the positive electrode, which is the anode, and the negative electrode, which is the cathode. What would happen here? And V, please, at anode, what's going to happen? What can you find at anode?
It attracts like element with negative charge.
So that should be SO4 2 minus and OH minus. And at cathode, we have Cu2 plus and H plus. So at cathode, what's going to happen? Hello? V. Cathode first. What's going to happen? Between copper and hydrogen, what is going to take electrons?
I think copper, because copper is more reactive.
Copper is less reactive, but copper ions are more likely to take electrons, right?
Yeah, I
Good.
mean the ion.
Okay. Now for the anode here, now this is a very special situation because this particular copper electrode here, the thing about this electrode is that between sulfate, OH minus, and copper is actually the easier one to lose electrons. Okay, so what happens here is that it's not OH minus, it's not SO4 2 minus that lose electrons. What you will see here is that this particular positive electrode will eventually get, hold on, this is not the correct drawing. This is a real observation. This thing will eventually just get eroded, right? As you see new layers of copper formed around here. Green, sorry, blue. And then you see a layer of copper formed here, copper. And this side lose mass. It becomes thinner. And the explanation here is because copper actually lose electrons faster than even sulfate and hydroxide ions. Okay? So in this case, in Vietnamese, we call it dương cực tan. And English, what is emphasized here is that when you use copper as an electrode, it will also react, okay? As well, the positive electrode, that is. So this is a special case based on a real observation. So write it down, please. It's a special situation. When you use copper as electrodes, especially the positive electrode, the anode, copper is going to react because copper is going to lose electrons before hydroxide and sulfate. Okay, so let me remind you that this is a real observation. It happens. So people tried to find an explanation for it. Okay. Joe, any question?
No.
Okay. Then we have one more part in the last part of the chapter here, the hydrogen-oxygen fuel cells. Okay. So let me just show you the diagram. Where's Viet? I can see Joe. Who's in the frame? The taller one is,
Mimi, I'm Cho.
and the other one is.
Yes, the rat-looking one is the Viet.
The what?
The beautifully looking one is Viet.
I can't even see his face. Wow. He's much younger than you are.
Yes, I'm his brother.
Really?
No, just kidding. We're the same age.
Well, you might pass for brothers for sure. Okay. Anyway, here. So this is what is called a fuel cell. Can you see what's going on here? I'll give you a bit of time. All right, we're going to restart this. Hold on. So hydrogen on the left, oxygen on the right. Can you see that? The gases, H2 and O2. You see that? Whom can you see it?
Yes.
Okay. Can you see that on the left, that is the um anode. Anyway, let's just see. Now, I want you to pay attention to what happens to the gases when they reach the electrode. From H2 to what? Okay. Now, Kang, please. H2 becomes what? Based on this diagram.
H2 become 2H plus and it loses 2 electron.
Good. And for oxygen, we can't see it, but let me show it. Here. This looks like O2 minus, right? So what's going to happen here is
The 2H plus combined with the O2 minus to form H2O, which is water.
and in this process, it generates electricity. Okay, so this is the principle of this hydrogen fuel cell. You essentially just combine hydrogen and oxygen in a particular way with the help of an electric current. Okay, and that helps to generate energy. And of course, the advantage of this particular process is that it releases a very harmless gas, a harmless product, in comparison to like fuels that are carbon based. Okay, good. Yeah, so that's it for the hydrogen cell here, oxygen cell here. What happens is that H2 will be broken down into H plus, and oxygen will be formed into O2 minus, and then they combine together to form H2O. Okay. Any question? V, any question?
No.
Okay. I'm gonna give you all a link. Hold on, let me give you that link. And I would like you to download some of the files so that we can zip through the questions. Have you finished this chapter at school?
We only started with the first part.
Are you the monitor of the class?
Yes.
Are you kidding me?
What can
Are you
you
being
see?
serious? So that's a genuine question. I want to take your word for it. Are you being serious?
Yeah. Yeah, I'm the monitor.
Your playful nature makes it hard to believe.
Yeah, and also the intelligence and the yeah.
Click on the link, please. You should see 3 files there. I guess I can just change access. But that means next week we can do a test. Yes, I know. That's how we work around here.
We need access.
You can refresh. I think I've already given you all access. I have a question.
Yes.
Is Chen Winchell really the monitor of your class?
Can you repeat the question?
Is Chen Winchell the actual monitor of your class?
What do you mean by the monitor of the class?
Lớp trưởng.
Yes, he is. He is the monitor of our class.
Who voted him in that position?
The whole class.
Really?
Yes. They are feared by my intelligence, my beautiful nature, and my face.
Beautiful nature and face. Isn't that an overkill?
No, I don't think so.
Okay. That sounds a bit hard to believe, but okay. Have you got all the file?
Yes.
Okay. We're going to go through a few questions. We're going to go through as many questions as possible. So the next 14 minutes, wow, Joe, that not Joe, not Joe, but Trúc An, that man behind you certainly has a prominent spot. He's saying hello too. Hi. He has white hair. I used to have white hair. I have white hair now, but back then I had to dye my hair to get the white hair. All right, question number 1 then. We're going to go through as many questions as possible, so keep your mic open. Here's the first one. Graphite electrodes. Forward cathode, what is that?
Cation.
What products?
Specifically sodium.
Nope. We have
What is
aqueous
it?
sodium chloride, so we have Na
Oh.
plus and H plus. So which one's going to receive?
H plus.
Good. Hydrogen. Let's continue. Question number 2 then. At which electrode is hydrogen formed. This is hard. And with decay in the background.
Aqueous sodium chloride.
You definitely need aqueous sodium chloride, but are we looking at positive or negative end?
Positive.
Now, you need negative end because that's going to attract cations. Okay? It can make it a bit confusing. So the electrode has its own charge, like positive and negative. The ions will migrate to these electrodes based on the principle of opposites attract. Okay? Got it? So the answer here is B. Let's continue then. Zamming.
Yes, Amir.
Question 3. Concentrated aqueous sodium chloride is electrolyzed using inner electrodes. What are the two gases here?
Maybe B.
Now, NaCl and water. So we have, what are the cations?
Na and H.
Na and H plus. So H plus is going to be collected at the negative electrode. Right?
Yes.
Good. This is concentrated aqueous sodium chloride. So for anode, which is the positive electrode, we have Cl minus and OH minus. For the concentrated version, which gas are we going to get? I mean,
You would have chlorine.
we're going to have chlorine. So the answer here is B. Okay. Now for V, you chose C, but it only applies to the dilute solution where you have more water than chloride. Okay. Good. The answer is B. Let's continue then. Question 4.
C.
Aqueous solutions using inert electrodes. Well, if you choose C, do you remember the example of sorry. So you definitely need two nonmetals here. But for negative electrode cathode, you can get either metals or hydrogen. So the answer is C. Did you say C?
Yes.
Oh, well then you're correct then. Question 5. Oh, wait, hold on. Yeah, we definitely need to go through this. Show please the monitor.
Okay,
Lead bromide.
so we have lead and bromine.
Yes, Pb 2 plus and Cl minus. Sorry, not Cl, but Br.
And it's molten, so there's no H2O.
Yes. Pb
Um,
goes to which electrode?
Pb goes to the negative, and
So
Br is the positive.
the answer is
Uh, yeah, C.
C. Kang, you stole his thunder. Viết Anh then. Aqueous nickel sulfate.
Nickel.
Which materials are used as the negative electrode and positive electrode? Think about it. You're trying to coat a piece of steel with nickel. So you definitely need to put steel somewhere. Let's say we have steel here.
A.
A.
Yes.
Let's check. If you use the negative electrode as carbon, here, negative, positive. If you use carbon here, so nickel is going to be here, right? It's going to attach to the steel thing. So you definitely need one of these two. But for the negative electrode, we're going to use nickel or carbon. That's the question now.
Wait, which group is nickel in?
Nickel is a transition metal. Oh, well then this is incorrect then. The problem here is that if you put steel in the positive electrode, nickel 2 plus cannot jump onto steel because nickel is moving to the negative electrode, right? Understand that part? So, sorry, who am I asking again?
Me, Mitchell.
Sure. No, so that's not the correct position. Okay, let me just do it again. You want steel to be plated, right? So you need to put steel where nickel is gonna go to. So is nickel 2 plus here gonna go to positive or negative end?
Negative.
Negative end. So that's where you're supposed to put steel.
Okay.
So the answer here is clearly
D.
D, right? And remember the whole thing about the Zoom Guptan situation? In the example that I gave you here. The syllabus only requires you to understand the principle through the example of copper electrodes, but that applies to other metals as well, right? So if you want to electroplate or you essentially you coat an object with a particular metal, you definitely need to use that very metal as the material for the positive electrode, right? So that's the overall principle, but that's not part of the syllabus. So I'm not going to jump the gun here. So, but still, you have to you have to use the positive electrode that is made of nickel. Okay. Next, then, Vidang, question 7. Molten concentrated. What are the products of the negative electrode or cathode? Now, for molten sodium chloride, we only have
UC.
Na plus, and then we have H plus and Na plus. So the answer is definitely C. Let's continue. We can jump through these questions. Okay, question 11 then. V. Concentrated aqueous sodium chloride and dilute sulfuric acid are both electrolyzed using inert electrodes? Cathode.
I think it's D, I'm guessing.
Cathode, you have to find cation.
Oh yeah,
So
I
for
didn't
sodium, aqueous sodium chloride, what do we get? You have Na plus and H plus. And for dilute sulfuric acid, you only have
HNCl.
that should be
Oh,
H2SO4. Okay. Well, in this particular situation, what are the products are we going to get between sodium and hydrogen? Which one is going to get electrons?
probably hydrogen.
Hydrogen. And in the second situation, only hydrogen is there. So, E.
Yeah.
Okay. Next, then, question 12. Let's go back to the top. Question 12. And
Wait, I'm still reading the question and choosing the answer.
let's consider them together. Number 1, is that correct? Dilute aqueous potassium chloride. So you have K plus.
K plus and Cl minus.
So cathode, is this correct?
It is.
Good. Anode though. Dilute. So we're gonna get OH minus or Cl minus.
We are gonna get OH minus. So
Good.
it is correct.
Second question then. Concentrated hydrochloric acid.
So it's gonna be H plus and Cl minus, and also H plus and OH minus for the water. So the product at the anode is correct.
So the answer is
1 and 2, which is A.
okay. Well, number 3 is obviously wrong because this is O2 and O2 does not go to cathode. That's the region of cation. And concentrated aqueous sodium bromide. Sodium is not going to receive anything. Good. Question 13 then. And carbon electrodes, hydrogen, oxygen are formed. So what could be the electrolyte here? Sorry.
It's B.
B. If you use hydrochloric acid, there's only Cl minus. So you're gonna get Cl2. Nope. You need hydrogen and oxygen only.
So it's gonna be A. I think so.
If you use copper sulfate, you're introducing Cu2 plus. You're gonna get Cu. Nope. Well, D is definitely wrong because you have potassium here, K plus. Okay, the answer here is C. Dilute aqueous sodium chloride. So you have Na plus, Cl minus, H plus, OH minus, right? It's dilute. So you're gonna get H plus and OH minus. If it's concentrated, you're gonna get Cl minus. Got it? And got it.
Yes.
Okay, let's continue. I want to jump to the questions here. Question 11. Where were we? Zamming. Movement. Cathode and anode. Ming, turn on the mic.
We are still reading the question.
Yes. Direction of movement of ions and electrons.
Maybe it's a
Well, the anode should have what kind of charge? Ming, mic on.
positive charge.
Good. And negative charge. So the electrons will go from where to where? From negative to positive. So that part is checked out. So Na plus will go to cathode, Cl minus go to anode. Check out. Nice. All the other questions here. Okay, question 21 then. Hưng.
B.
Next then. You can, and it's electrolysis. We can skip this question. There's 23 then. So oxidation is occurring at electrode 1 and reduction at electrode 2.
Yeah.
This can be confusing.
Which
This is oxy. This is reduction.
so oxidation
Is losing or gaining electrons.
losing electrons, so it's the anode.
Lose electrons. Lose electrons.
It will be the anode,
Mm.
and the other is
So
the
the electrons will come in.
yes, come in 1, 2, 2.
So that means this one's gonna go out.
Yeah.
Okay. Well then what is the direction then?
Positive ion will go to
Positive ions in electrolytes will go from where to where?
so like 2 to 1.
2 to 1. Redox. So redox is cathode.
So
So the positive ions should go to cathode.
so like 1 to 2. So it's A.
Okay, good. And for the movement of electrons in the, hold on, external. The problem is external. So internal will be the internal, but external here would be from where to where? From here to here. Because it goes like this. So to continue the circuit, it has to go from left to right. That should be 2 to 1.
So it's C.
C. So that's the concept of external circuit. Any question thus far with this paper? Move on, any question?
No.
We're gonna move on with 5 more questions and then I'm gonna let you go. Hydrogen oxygen fuel cell. I'm gonna go down here. Question 6 then. Châu. Oh, sorry, Việt Anh. Which statement about the hydrogen oxygen fuel cells is correct? You can certainly single out the answers that are wrong.
In D.
So D, the answer here is D. Correct. So I mean C is wrong, B is wrong, and hydrogen is not extracted from clean, dry, not dry. Okay. Question 7. V then.
I think both are correct.
Right? Can react to produce electrical energy. That's a yes. And hydrogen and oxygen can be made by electrolysis of aqueous dilute, by the way. Good. Now, if it's not dilute, if it's concentrated, then what is the product that you're going to get? V. V. Is V still in the building? You see it, right?
Yeah, I'm still here. Just wondering.
If it's concentrated, what are we going to get? We're going to get chlorine. Okay. Question 8 then, just a few more. We're going to go back to the top bảo khang.
So 1 is correct, so I can rule out C and D. 2 is incorrect. 3 is correct, and 4 is incorrect, so I choose what A.
Correct. Let's continue. Chúc An, where's DK? Question 9. Oh, this is so obvious.
I think it's A.
It's hydrogen oxygen fuel cell. In that diagram that we saw, we saw only hydrogen and oxygen.
Oh,
So you should get only
water.
water, right? It's a hydrogen oxygen fuel cell with the help of electricity, right? So only water is formed. The thing about carbon dioxide and oxides of nitrogen is that you're using like normal internal combustion engine. You have that spark to trigger the reaction, but that spark, the spark here to burn, let's say not CH4, but essentially you burn some sort of hydrocarbon to give you CO2 and H2O. But that spark is very similar to a lightning spark. So that can also trigger the reaction between nitrogen and oxygen to give you oxides of nitrogen. So D. And one last question. Yes. Zaming, please.
For question 10, maybe COD? C.
Methane is a good fuel because it produces only water. CH4 here, it's legendary for producing CO2. So not C. And uranium, this is a radioactive metal. Nobody burns it. No. This thing is radioactive. So what is the answer here?
B.
It's B. Hydrogen is used as a fuel, although it's difficult to store. Hydrogen is extremely light. And also, if you let one spark of fire escape, that's one, it's not a hydrogen bomb, but that's a bomb for you. Okay. All right. Well, your homework would be the rest of the two papers, these two MCQs papers. Wow. And you have finally survived this lesson. And you're yawning. Really? Any question thus far? And Joe, why are you clapping?
I clap for Bảo Khang.
What exactly did Bao Khang do?
He just staring in the void.
Okay. I have no idea how this class works. Your dynamics are so weird. You don't even have each other's contact numbers. What
No,
if Hung was abducted? What if
yeah.
he fell in his bathroom? What if, even worse, what if he was in the bathroom and he had no toilet paper and no bidet?
I have
See through the
everyone
camera.
contact. I have everyone contact here except him.
Oh,
So
Yeah.
well
the
then,
problem is from him, it's not us.
It's more of isolation.
Hung, do you have anything to say for yourself?
We all have each other contact except him.
Oh, did I pass contact for him? From him? I don't know.
Well then, why did you call him up?
He fake friend.
I know Hưng is sleeping.
Can you try to just let him sleep, dreaming about his prince or his princess?
Like I know I can't wake him up from his sleep.
Hung, is that true? If you fall asleep, who can wake you up?
Myself.
This answer. Okay, well then that's it for today then. Bye-bye.